Alright, you are welcome to this session again with Prince Maths Clinic, and on the board we have this interesting question: to find the value of x in log 2 base x plus log x base 2 equals to 2. For us to be able to carry out this particular operation, it is necessary that both log need to be in the same base. This is log 2 base x, and here we have log x base 2. We can't work with it like this. We either change this to base x so that both of them will be in base x, or we change this to base 2 so that both of them will be in base of 2. Therefore, to proceed, I will have to take the log of log x base 2 to base x. So that's what I will do. What I want to do, I will write out that log of x in base 2. Right? So this is what I will do. I am going to write out log and put x here. This x is what I'll write here. Log x, then divided by, then this 2. Here I'll write it here, log 2. Because I'm taking it to base x, I'm going to put the base here as x. Because of this x, I'm taking the both base 2 and x. And we know that when a log and a base are the same, it cancels out. It turns to 1. Then here I have it as log 2 base of x, which I'm going to use to replace this particular part in the question. So therefore, I will have it as log 2 base of x plus, now this is no longer log x base 2 because I've converted it to this. So since I've converted it, I will now write over plus 1 over log of 2 in base x, now equal to 2. Good. Now since I have it that way, what do I do? This is now log of 2 base x. It's as good as saying over 1 plus 1 over log 2 base of x, that is equal to 2. So what do I do from this stage? Remember that you have log 2 base x here. So I am going to say put 2 base x equal to p. So anywhere I see log 2 base x, I will represent it with p. So this will be p over 1 plus 1 over p, everything equal to 2. Then here I would like to use the butterfly method, use here to multiply here. So p multiplied by p will be p squared plus 1 times 1 is 1, then over 1 times p is p, equal to 2. So this leaves me with a quadratic expression that will look like this. This becomes p squared plus 1 equal to 2p. Good. So since I have it like that, I want to collect like terms now. So if I collect like terms, that will become p squared minus 2p plus 1 equal to 0. Now let's look at the equation again. The equation we had was plus 1 minus 2p. Now when this 2p crosses over to this side, the sign will change to negative 2p. That is exactly what happened in this equation. Good. So solving this equation quadratically now, open two brackets, 0, put a p here, put a p here. Now 1 times the coefficient here, which is 1, is 1, and here I have minus 2. What are the two numbers I will multiply that will give me positive 1? That if I add them up, it will give me negative 2. They are negative 1 and negative 1. So if I say minus 1 times minus 1, I will get positive 1. And if I add minus 1 to minus 1, I will get minus 2. So therefore, when you have two factors equal to 0, it is either of the factors is equal to, either of the factor is equal to 0. So therefore, I can say p minus 1 equals to 0. Hence, p is equal to 1. But recall, we have to recall that we said that what? Log 2 base x is equals to p. Now that p is 1, therefore we can say log 2 base x is equals to 1. And remember, when you are converting from log to indices, the base here carries this as the power. So therefore, I will say x to the power of 1 is equals to 2. And x to the power of 1 is still the same as x. So x is 2. Good. So let's check to see if we are correct. Remember, the question given to us is what? Log of what? 2 base of x. And we said that x is 2. Then plus log of x base of 2. And we found our x again to be 2. Now when the log and the base are the same, it cancels out to become 1. This is 1. Then cancels out, this is 1. And 1 plus 1 equal to 2. Remember, the question was equal to 2, right? Good. So this is it. Therefore, it then means that 2 is the correct solution to what we have done. I hope that is clear. Kindly subscribe to this channel if you are here to do so. Invite your friends, and together we will all enjoy mathematics. Bye for now.